Hi everyone, I'm Victor. Thanks for having us here. Thanks to SF HTML5 for arranging this wonderful meetup. I work for Goo Technologies, based in Stockholm, Sweden, and with me today, as Peter said, is another Peter from Gazing, based here in California. And as a colleague of mine put it, WebGL is very good at solving a very specific computer science problem of today. And that problem is to get the highest amount of likes per line of code. The measurement to keep track of the next few years will be LPL, the likes per line. And we've seen, as we've seen in the previous talks, that, for example, Chrome experiments collecting a lot of really cool hacks of WebGL wizardry and WebGL examples from people that know this really well. But the question now is, how do we get this into more hands? How do we get WebGL into the hands of all the creators that are out there? And this, of course, can be graphics wizards and game developers and hackers, but it can also be artists, architects, teachers, advertisers, interface designers, and so on. How do we give them the power of WebGL? And the answer to that question is we build pipelines and we design workflows. Because not everyone dreams about spending all their Friday nights with shader debugging. I know it's really hard to imagine those people exist, but they do. So the first step, as we've already seen also, is to get a 3D engine going. It takes care of all the low-level WebGL stuff that we don't want to do every time. It gives us a nice API to play with. And one thing that I think is very important when we do this is that we try to use open web standards as much as possible. In this case, it means nothing but JavaScript, HTML5, and of course WebGL. Because what happens then is that a lot of people know JavaScript. And suddenly they now have tools to also kind of know 3D. And it also means that you don't have any plugins or any downloads necessary to share your work later. So I want to show you some more demos. So that's kind of why we're here, right? So this first demo can show you that not only can you render cool 3D stuff, you can also integrate other things in this, like, for example, video, like in this case, once you decide to use all these open standards. The other demo I want to show is this one. It's something that we've, let's see, so many sliders. I need more resolution, Peter. Where's the resolution? Oh, there we go. Now we see the slider, and I can click that one. Sorry about that. There we go. This is a demo of pretty much a full-fledged flight simulator of a really old Swedish fighter plane. Those exist. Actually, it's a thing. I did not make that up. This screencast is running in, is recorded in Chrome, and it's something that we have developed internally while we are at Goo are building our Goo Engine. Because it turns out it's not easy to build a pipeline, and it's really hard to define a workflow, and you need people to kind of tell you how they want it to be done. So this is what can be done, of course, and it's really useful to have people in-house to do that kind of stuff. Let's close that. So that's great. Now if we have a couple of different 3D engines and open web standards that we can use, but what do we do about the people that don't want to code or don't know how to code? Well, the answer is, again, we build a pipeline. We build more things. We build a pipeline that can handle things. So if you have a model of a really old Swedish fighter plane and you want to get this online, you need a way to do that. And you need a way to do things with it visually without necessarily writing code all the time to move things around. And then, of course, you want to be able to share it with as many users as possible to get as many likes as possible. That's the whole point. So I'd like to show you a tool that does try to solve part of this puzzle. And this tool we call Goo Create. Looks like this. And this part here to the right is the 3D canvas where the 3D engine will put all the stuff and render that. The interface that you can see to the left here is built using a very, very, very large amount of Angular. And behind all this, there's a Python backend running. And the backend takes care of exporting and importing models into a format that the engine understands, but it also fills the very important part of managing users and projects. Because in a pipeline, of course, you want a place to do your things. You want one place to store all your work. So the way this works is, say that you have a 3D model that someone built. In this case, saved in an Collada, kind of large FBX file format. And what you can do here is you simply, if we can get all the windows to see at the same time, you can drag and drop this onto the canvas. And once the backend has converted this to a model, a format that the engine understands, we can start to interact with it. So there we go. Now we have this 3D model here, and I can start interacting with it. Looks kind of creepy right now, but luckily the designers thought of that and put some materials and textures onto this. So clothing, for example, what we can do here now is do some more dragging and dropping, because I happen to have textures in a standard PNG format here. So this was the clothing. So let's see if we can see what happens here. Drag and drop that onto the model, and then we can do the same thing for the hair. There we go, and for the skin as well. There we go, and that looks a little better, right? And this interface lets us interact with it and add things like sounds and cameras and lights and so on. And this model happens to have an animation. So if I press play here, we can watch it and see it in real time without writing any code. So let's try to add a light, for example, and see what happens. Add a light here, and we can start moving that around, set some parameters, and see the scene change in real time, fully interactively. It's all in the browser. It's not using any plugins or any downloads like that. And let's go to my favorite panel, and it's the post effects panel. It's very good for likes, very good for likes. So if we want to add some glow to this, okay, that's a bit much. Maybe we'll tone it down a little bit, or some grain. We can add some movie vignetting, etc., etc. You get the point. And once we're done with the scene now, thanks to that we have all these awesome web standards to play with, we can share our work very easily by just basically clicking a button, bundling everything up together, including the engine and the data format, and push this to a website. And now if you have a decent WebGL compatible browser on your tablet or your phone or your computer, on your refrigerator or your washing machine, you can surf into this website and look at this right now, actually. I'll give you a tiny URL version of this in a minute. And of course, if you want to code, you can do that as well. You can export this into a JavaScript template and add your own code and then keep working on that, because we like to code, right? Now, so if you want to try this out, you can do that. You can go to that tiny URL and you'll see the same link. Or you can sign up for the beta. It's free right now if you want to try the tool out. So what happens now? What's next? Now we have all these things. I can take my Swedish fighter jet model and put it on the internet, but we need to think about what happens in the future. And I want to talk a little bit about the funnel. It's a kind of a pipeline, right? You take a lot of input, and you get a very defined one kind of output. So here's my invention. It's the double funnel. Probably the worst invention ever made, if you would ever use it in real life. It's really hard to get venture capital for it, but if you want to talk later, we can do that. But it illustrates the point here. We want to take a wide array of inputs from different people in different formats for different purposes, use the tools that we have, and then push it out to different distribution channels, cooperation ways. We want to push this to games, to apps, to programs, whatever, you name it. So, the double funnel. It's the future, promise. And demo time again, of course. We like demos. I want to show you a little bit more complete product built on this Goo Engine. This is the same guy that we saw earlier, and this one I can make him roll around here by pressing standard keyboard control. I can turn him around and so forth. It's all done interactively in real time. And I mean, a mouse and a keyboard is fine, But if we want to kick it up a few notches, Peter, what do we do then?
Microphone. Yes, excellent. Thank you. Great. Thank you, Victor. This is awesome. So what we have seen is that you can add extra layers and tooling on top of WebGL, and by doing so, you can make it accessible to those who are not necessarily coding. So what I wanted to discuss a little bit is how we can use related HTML5 technologies to improve the WebGL experience. Specifically, the area that we are focusing on, and I've been focusing on in the last couple of years, is real-time web communications and how you can improve this experience. So what I've done here is I pulled up a remote control on my browser. The remote control on my phone is running in Safari without having installed anything. I have a URL that I went to, and by simply tapping the buttons here on my phone, I am sending messages to the application that's running here on the desktop. So what is happening here behind the scene? My phone is on the AT&T LTE network, and it has a means to send very low latency, very small messages to my PC over here. So let's take a very quick look at how we can achieve this kind of experience. Let me do a little bit of dancing here. So I have my desktop app pulled up. That is a web browser on the top. And on the bottom, we see my Safari browser. Both of these HTML5 apps are connecting to a WebSocket server. The WebSocket server has the ability to receive and send messages. So very much like, thank you, very much like in the world of HTTP, you do need a WebSocket server for WebSocket communication. The fundamental difference between the REST-based world and the WebSocket-based world is that you have the ability to keep this connection open between your client and the server and send these messages with extreme low overhead back and forth between the server. So my desktop application is not sitting there and polling the server, is there a new message for me? Is there a new message for me? It's just sitting there idle. And whenever I press a button here on my phone, the WebSocket server passes that message to the application, and let me close this. And it allows us to navigate on the screen. So a few words about this communication technique. Originally, it was designed to bring the same power to web applications that we have in the world of any connected application in the TCP world. So now you can say that whatever app there is out there, whatever connected app is out there in the world of TCP, now we can do that over the web. And this gives us an incredible power to improve our WebGL and non-WebGL applications. So we have this permanent connection and allows us to build these event-driven applications, which is a major shift from having REST-oriented request-response kind of applications where the client is requesting information from the server. Now you have the ability to send these messages freely back and forth. When you are building a networked application, you are not going against the low-level network API or the protocol. You are building an email application or a chat application, there's a good chance that you are using something like IMAP or SMTP for email or XMPP, Jabber for your email client. WebSocket, as the standard, was designed to support these higher-level, richer protocols. So in our case, you can build very easy PubSub experiences, PubSub APIs, that allow you to build these apps very quickly and very easily. Not only that, WebSocket was not designed to be there exclusively for web browsers. It was designed to be agnostic to the client. So you can build native mobile applications. You can build Android, iOS applications natively. Not only that, you can build desktop applications. You can have a .NET, a Flash, or a Java application that can have this kind of real-time communication all over, going all over the web. So again, remember, I had a browser-based app running here in my phone. I was connecting to the network over LTE. I pressed the button here, and that message was sent to the WebSocket server, and it bounced back here to my laptop. That WebSocket server that I was communicating with is in the east coast of the US, 3,000 miles away from here. So it had to cross the continent back and forth to get this data here across. Okay. Now, I wanted to show an example how this can be elevated even further. Everybody brought their awesome 3D designs and awesome 3D models, and I decided to bring mine. So here I have my 3D model. Just look at the textures here. Look at the reflections on the design. It's pretty impressive. So what is this? We went out to Toys R Us and we bought a radio-controlled truck. And after driving it around a little bit in the office, we said that maybe we can do it better. So we ripped out all the radio-controlled functionality, and we glued a credit card-sized little computer onto the back of the truck. And what this does is it has USB ports. You can attach a little Wi-Fi card. It has an Ethernet port. It has an SD card that you can put the operating system on. But most importantly, it has the ability to control external electronics. It has a notion of a general purpose input-output port that allows you to control, let's say, a car. You can drive it around, in our case. We have 3 pairs of these adapters, and I'm going to attempt to show that to you in a minute. Now, I could drive it around the same way I was trying to control, or I was controlling the Leap Boy on the screen, or the Pearl Boy on the screen. But my favorite way of showing this kind of demonstration is having somebody very far away, maybe continents away, Skyped in, and have that person control the truck. Now, we have some network limitations here, and we couldn't achieve this, or couldn't quite do this, set up this networking. But I brought the experience to you, so I'm kind of doing these acrobatic tricks without the net underneath me. So we'll try to do this. So what is going to happen is I will bring up a page, and in this page we are going to do a video call. So in the top left corner you see me, and in the middle of the screen you see David, and David has this ability of sitting there very patiently and not moving at all while he's waiting to control the truck. Let's see if we can have a chat with David. Hey, David, can you hear us?
Hello. Can you hear me?
Yeah, we can hear you. Hey, are you online?
Oh, well, yeah, we're on a video call right now, so I think I'm online.
Yeah, that's a good point. Hey, we have a truck here that we could use.
Truck?
Yeah, truck.
I thought we were going to be controlling a drone.
No, we had to cancel the drone project.
Oh, okay.
Can you help us with the truck?
Yeah, absolutely.
Okay, so what are you going to do?
So I have the controls pulled up over here on my phone.
Okay.
So if you hold up the truck on your end, I can actually turn on and off the lights. So on, off, on, off.
Very cool. Can you turn the front wheels left and right?
Yeah, absolutely. So right, left, right, left.
Very cool. Can you spin the wheels a little bit?
Yeah, so forward, reverse, and forward, reverse.
Very cool. I'm going to put it down on the floor. Can you control it there a little bit for us?
Sure, let me know when you're ready.
Okay, we are ready, but be gentle. Very cool. Awesome. Thank you, David.
Oh, you're welcome.
Very nice.
So next time, remember to bring the drone.
We will bring the drone for you. Don't worry about that.
Bye.
Okay, take care. So, thank you. So what you have seen is magic. Basically what we did was we have a web browser running on a mobile device that can be on a carrier's network that has the ability to send real-time messages to any web application out there, or any WebSocket client for that matter. In our case, it's Java code running on the Raspberry Pi. If you're interested in how this experience was created here for you, you can just Google here in the bottom right corner. You Google for WebSocket and Popcorn. Popcorn is an awesome media library, and you can do these nice experiences with it. There's a blog post that we just put out. You can read all the details. Now, what do we do? What do I do when I am not here and having fun and meeting nice people at meetups? There are many, many challenges in the real-time web communication space that make it really hard and challenging to build and provide seamless experiences. There's a notion of firewalls and routers. Your connection gets broken down because you are in a tunnel. Maybe you need to scale out to millions of users because you become very successful suddenly. These are the kinds of problems that we are trying to solve, and we are very busy solving at Kazing. So, if you want to learn more about Goo, how Goo enables web developers as well as creative people, here are a handful of links for you that you can go to. Goo is going to have, or is having actually, a beta program, and you're encouraged to sign up to those. And if you're interested in any of the real-time communication aspects, how you can bring this kind of power to your WebGL apps as well as to the physical world, you can visit the links on the Kazing site. And last, here's the contact information for us. Thank you very much.
All right, thank you.